Hey guys, welcome back to my channel Akail Avi. In the previous video, we talked about what is crystal, and in this video, we will learn Bragg's law. So, just start. Actually, the regular interatomic spacing in crystals may be determined by diffraction of X-ray photons. In 1912, Max von Leu he realized that the interlayer separation of atoms in a crystal is of the order of 1 angstrom. So, a crystal may be used as a diffraction grating for X rays, which also have wavelengths of the same order. Soon, this idea was successfully applied by W. L. Bragg and W. H. Bragg. And interesting that they were son and father pair. So they started to make some research on this and they took sodium chloride crystal. They saw that when a beam of monochromatic X-rays strike a layer of atoms in a plane of some crystal, most of the X-ray photons pass undeviated through this plane, but a small fraction of the photons gets scattered after colliding with the electrons in the atoms present in that plane. That means if we pass some waves, most of the waves will be get through, but some will collide with these ions or atoms and just reflect back. The second layer of atoms in the next parallel plane of the crystal similarly scatters a photon of the X-ray reaching this layer, and the process is repeated for successive parallel planes. This is the second layer, this is the first layer, this is the second layer. In all layers, the wave will be diffracted. Now, the rays scattered from successive layers will reinforce each other only when they are in phase and able to form constructive interference. This will result in a high intensity of the scattered beam. So this was the idea which the Bragg, the son and father pair, which have used. So I have just represented that and I have magnified this portion here. This is the first ray coming and getting scattered. This is the second ray which is getting scattered from the second layer, and I haven't shown the further third, fourth layers scattering. So now look, this angle, we say this angle is theta. So this angle will also be equals to theta. Now this is theta and we have drawn OM perpendicular to this line from this O. So this angle is 90 degree, this angle is 90 degree, and even this angle is also 90 degree. This and this angle is 90 degree. And now this one is theta. So this one is 90 minus theta. Now this AOP, this angle is also 90 degree and this is 90 minus theta. So this must be theta. Okay, do you understand? Let's see it again. This angle is theta and this is 90 degree. So this will be how much? This will be 90 minus theta. And again, BOP, this angle is 90 degree. This is 90 minus theta. So this also be theta. Now, with the respect of this angle, look, what is the value of sine theta? Sine theta gives this PM by OP. So sine theta is equal to PM by OP from this triangle, and from this triangle, sine theta is equal to PN by OP. So with a brief calculation, we have just got PM, this value PM is equal to PN equal to D sine theta, as OP is the D, the spacing between the crystal layers. Now the wave, just look this and this. This second wave has to pass the this much extra path. So the path difference is equal to Pm plus Pn. And actually Pm and Pn is equal to d sine theta. So Pm plus Pn is equal to 2d sine theta. Now, what will be the phase difference? Phase difference will be a multiple of lambda, which is the wavelength of the incident ray. Rather, we say wavelength of the incident X-ray. And n is any integer, starts from 1, 2, 3, 4, etc., etc. So we get that this phase difference and path difference will have to be equal for a constructive interference. Thus, we get n lambda is equal to 2d sine theta. This is very much simple. You can just see it again and you will realize the everything. So this much for this video, and in the next video we will see different types of unit cell and their symmetry. Thank you.